So let's do a problem where we actually are going to have two different triangles. So suppose that you have these angle measurements and the side measurements. So you want to determine if one, two, or no triangles exist. So, and let's solve for the triangles if they do exist. So I'm going to start off by drawing my triangle. So now we're given A, this is 61.4 degrees. And then you know that little a is going to be opposite of it. You got B, which is going to be 39.2 centimeters. And then you got big B over here. So little c's there, big c's there, and little c's there. Okay, so first let's start off by doing the law of sines. So you have sine A over little a. It's going to equal to sine B over little b. So sine A is going to be the sine of 35.5. Oh, no, that's wrong. The sine of 61.7 divided by 35.5. And then sine B divided by 39.2. Okay, so now let's cross multiply. So you're going to have 39.2 sine of 61.4 is equal to 35.5 sine of B. Okay, so let's divide by 35.5. So then you're going to have sine B is equal to, whoops, not sim B, sine B. Okay, so let's see what that is. So that's going to give me, okay, so 39.2 sine of 61.4 divided by 35.5. So that's going to give me 0.97. Okay, so that's good. That means we're going to be guaranteed a triangle. So that means it's going to be your B1. So sine inverse of 0.97. Okay, so what I ended up getting was about 75.8 degrees. Okay, so that's what I ended up getting. So now what you kind of have to ask yourself is, does a second triangle exist? And the reason why we have to do this is because we have the angle side case. Okay, so remember that the way that we do it is we need to figure out what B2 is. And then we do that by taking 180 and subtracting it by whatever B1 was, which is going to be 75.8. Okay, so let's figure that out. So it's going to be 180 minus 75.8. That's going to give me 104.2 degrees. Okay, so that's technically what B2 should be. Now, does it exist? Well, the way that we do that is we got to take our original angle and add it to this B2. And hopefully this is less than 180. Okay, so you're going to have 61.4 degrees. You're going to add it to B2, which is 104.2 degrees. So 61.4 plus 104.2, that gives me 165.6. So that means that this is less than 180 degrees. So you have two angle measurements that can exist, and you still have some of it left over for an extra angle. So that means two triangles exist. Okay, so two of them are going to exist. So now what we got to do is figure out what they all are. Okay, so the way that I'm going to do it this case and now is I'm going to start off by writing down everything that I know. Okay, so I'm going to kind of try to organize this a little bit. So I'm going to here have the first triangle, and then I'm going to write my work for the second triangle. So let's figure out what we have. So I know what A is, 61.4 degrees, and I know what little a is. That's 35.5 centimeters. I know my first B1, my first little B1 was 75.8 degrees. And I know what my B was. That was given to me 39.2 centimeters. Okay. I don't know what C1 is, and I don't know what little c1 is. So I'm going to leave it as is. Then for my second triangle, A is still the same, 61.4 degrees. That was given to me. So was A, little a. Now I have a B2, which is equal to 104.2 degrees. That's what we figured out here. And then your B still is the same, 39.2 centimeters. And then I don't know what C2 is going to be, or little c2. Okay, so we got to figure out basically the C's now. Okay, so I'm going to start off with the first triangle. So basically, I can easily figure out what C1 is. Just take 180 and subtract it by the sum of the two angles. Okay, so I'm going to take 180 minus 61.4 and 75.8. Okay, so I ended up getting 42.8 degrees. So this guy's going to be 42.8 degrees. All right, and now let's figure out C1. So in this case, I can use any angle that I want. So I'm going to use A. Sine A over little a equals sine C1 over little c1. So I'm going to have sine of 61.4 divided by 35.5 is equal to sine C1, which is 42.8, divided by little c1. Okay, so I'm going to cross multiply, and I'm going to get C1 sine of 61.4 is equal to 35.5 sine of 42.8. So I'm going to divide this guy over. Okay, so this goes away. So I'm left with C1. So 35.5 sine of 42.8 divided by sine of 61.4. So that's going to give me 27.5. And this is, I think, centimeters. So this is 27.5 centimeters. Okay. All right, great. We got our first triangle. But now we got to solve for the second triangle. Okay, so we're going to do exactly the same steps now. So let's do that in green. So C2 is going to be 180 minus the sum of these triangles, which is 61.4 and 104.2. Okay, so it's going to be 180 minus 61.4 plus 104.2. So I get 14.4 degrees. Okay. Alrighty, so now what we got to do is figure out C1. So we're going to do the same thing. Sine A over little a equals sine C2 over little c2. So I'm going to have the sine of 61.4 divided by 35.5 equals the sine of 14.4 divided by little c1. Okay, so let's cross multiply. C1 sine C61.4 equals 35.5, the sine of 14.4. So let's divide by the sine. Okay, so let's get rid of that. So C1 is, no, that should be C2. So C2 should equal to 35.5 sine of 14.4 divided by sine of 61.4. And I ended up getting 10.1. About 10.1. Okay, so here is my second triangle. Okay, all right, so this is basically how you would do a problem. These take a very long time, so hopefully we don't get two different triangles and we only get one or none. But you can expect in the exam that there will be a problem, only one, where you might have to solve for both different triangles. Okay, so we'll finish up this video by doing this last problem. Here what we have is a satellite is orbiting Earth as shown in the figure below. So the satellite passes directly over two tracking stations A and B, which are 69 miles apart. So basically what that's saying is that from here to here, these guys are 69 miles apart. So when the satellite is on one side of the stations, the angles of elevations of A and B are measured to be 83.9 degrees and 86.2 degrees. Okay, so we end up getting those angles of elevation. And they're drawn here. So how far is the satellite from station A, and how high is the satellite above the ground? So you kind of are looking at a couple of things. So the first thing is that you want to figure out how far is a satellite from station A. So you basically are looking for this distance. So let's just say D is a distance. Okay, so one of the things that you can do is let's try to break up this triangle. So here's kind of like what you're gonna have to do. So here, this angle is gonna be 83.9 degrees. We know that this guy's gonna be 69 miles. Now, I wish that I knew what this angle was. Well, we do know what that is because I know that this is 86.2. And if you remember, this is a supplementary angle. So that means all I gotta do is take 180 and subtract it by 86.2. Okay, and that's gonna give me what the other angle is because they're supplementary angles. So 180 minus 86.2 is gonna give me 93.8. So that means this guy is 93.8. Okay, and now we're just looking for this angle D. Now notice here that I can easily use the law of sines, okay? Now if I know what these inner two triangles are, then I know what this inner angle is also. All I gotta do is just take 180 and subtract it by these two angles. So if I take 180 and I subtract it by 83.9 and 93.8, then I'm gonna get the other one. And what you're gonna end up getting is 86.2 degrees. Okay, so this guy is just going to be 86.2 degrees. That's wrong. I can't add. This is going to be 2.3 degrees. I don't know what my calculator is doing. That didn't make sense. So that's going to be 2.3 degrees. Okay, silly rabbit. Okay. All right, so okay, so that's what we have right there. So now in this case, notice that I can easily use the law of sines to figure out what this distance is going to be. So all you can just do is use these two angles, okay? So use this 2.3 with the 69. So the sine of 2.3 divided by the 69, okay? And then using this angle, the 93.8, so not sine of 93.8 divided by this D, which I don't know what that is, the distance. Okay, so let me just cross multiply. So D sine of 2.3 is equal to 69 sine of 93.98. So I'm just going to divide by the sine. Okay, so D is going to be approximately equal to, so that's going to tell you how far it is. So 69 sine of 93.8 divided by sine of 2.3. Okay, and I ended up getting 1,715.6 miles. Okay, so that's how far away the satellite is from station A. Okay, oh, you wanted whole miles, so it'll be basically 1716. Okay, all right, now there's another problem that they're asking us to do. So it says, how high is a satellite above the ground? So notice here that this guy, you're just basically are looking at this particular height. Now the good thing is that we already know what this guy is. So if you look at station A, so let's say this is the ground, here's station A and here's a satellite. We know what the distance is from here to station A. It's just 1716. If I were to just draw this directly down, okay, that's going to form a 90-degree angle. Okay, and we already know what the angle of elevation is here. That's just going to be 83.9. So 83.9. And now all we got to do is just figure out what this distance is. So let's just call it height. Okay, so this is just something that we can just do just using the regular sine. So sine of 83.9 is going to be equal to the opposite over the hypotenuse. So that means the height is just going to be 1716 sine of 83.9. Okay, so let's just put that in our calculator. So we're going to have 1716 sine of 83.9 degrees. That's going to give me 1706.3 miles. So that's how far the satellite is above the ground. Okay, so doing a little bit of law of sines, a little application of where you can use the law of sines, and also kind of a little bit of, oh, don't forget about right triangle trigonometry.